So let's do this synthesis problem. Let's say this is our starting material, and we want to turn this starting material into this product. We have to figure out what reagents to add to turn this starting material into this product. That was good work. So some of the good things that you did there, you put in your stars for the carbonyls. One thing that might have helped is then to put in this star to show that this used to be the carbonyl carbon. But we should not put a star on either of these oxygens, because these are not the carbonyl oxygens. We know if these were the carbonyl oxygens, they wouldn't have R's on them, they would have H's. Okay. So these are not the carbonyl oxygen. So the carbonyl oxygen must have left as water. So that's not in here anymore. And also, a good thing that you did is that you labeled the carbons. You said this was A, and this was B, and this was C. Me personally, I prefer numbering. 1, 2, and 3. But letters are fine too, whatever works for you. And so the key thing is to show that this is the same carbon as this one here. So I tried to make this difficult by kind of rotating the molecule, but that didn't seem to phase you. I rotated this over here, but you still found who was the 1, 2, and 3. And then you said, gee, I know that those, even though these don't look like alcohols anymore, they came from alcohols. Here's where numbering can help again. We could call this maybe 5 and 6. So the alcohol we need here has to have this number 6 and this number 5 carbon. So that's good. This is what you drew. Good. And we need 2 equivalents of this, although like I said, a lot of the time people don't actually say that they need the 2 equivalents. How would we know to even have thought of this whole thing if we hadn't just been working on this reaction? Well, we should see this as a hidden carbonyl, because it's a carbon with 2 bonds to oxygens. And we know that a carbon with 2 bonds to oxygens probably came from this type of reaction over here. By the way, what is this? Hemi-acetal, hemi-ketal, full acetal, or full ketal?
Full ketal.
Good. And we know that comes from acid-catalyzed attack of alcohols on carbonyls. So the only mistake that you made is that you drew that the acid and the alcohol have to be added in separate steps. You wrote that like this, 1 and 2. But if you number these, that means they're supposed to be separate steps. That actually would be incorrect. The acid should be added at the same time as the alcohol. After all, we're going to need the acid throughout the reaction, right? Notice how the acid keeps darting in and out to add protons or remove protons. So we don't want the acid just to do its job and then the alcohol to do its job separately. So these should be put in together. So this number 2 here, this doesn't mean that this is a second step. This just means we need 2 equivalents of this. This is just a number 2 for 2 equivalents, not a number 2 to say that's a second step. Other than that, I think that was the only mistake you made, but that would be, you would definitely lose credit for that. These do have to be added simultaneously.
Okay. It'd still be under the line though, right?
Oh, it doesn't matter whether it's above the line or below the line, probably. Maybe I should have put them on the same side of the line, though. That would have been better, actually. You know that on your instructor's tests, he gives you little boxes to write write them in. Well, the key thing is you want to put these in the same box.
Okay.
These have to go in the same box, not 2 separate boxes, because these are the same step. So on your instructor's test, it would look like this. We might have gotten confused about that because earlier when we were doing category 1 reactions, we saw some category 1 reactions where we did have 2 steps. First we added the Grignards and then we did the aqueous workup. But this is not a 2-step. This is where we just add 1 step. Good.
And going backwards, there's just one step of H3O plus.
That's right, now that's the next thing we have to go over, so let's see how that works.